this question, the first thing to notice is that you, of course, have a denominator, and you have a denominator with one term in the denominator. And you kind of get excited about that because that means you don't have to go through the quotient rule. When you have one term in the denominator, what can happen here is you can split it up into two separate fractions. So what we could do is we could write this as, so this is kind of like my little simplification step before I differentiate. I would have 7 over sine x and then plus cosine x over sine x. Now, what you notice in that simplification is you still have the variable x in the denominator. So you kind of want to try to get that variable out of the denominator. So what you could do as part of your simplification is you could use your trig functions to rewrite this, to write x in the numerator. So once you get x in the numerator, then you won't have any quotient rule required. So that's the whole reason why we're kind of interested in getting our trig functions so that we don't have the x in the denominator. So if you look, for example, at 1 over sine x, that is equal to cosine x. So what I could do here with this 7 over sine x is I could rewrite it as simply 7 cosecant x. Okay, and I think I said cosine x, but I meant cosecant x, of course. So we have 7 cosecant x here, plus, and then our other identity that we know from trig is cosine over sine becomes cotangent x. Now, the great thing about this is once you use your trig functions, now your variable x is in the numerator, and we actually have our derivative rule for cosecant and cotangent. We say that for those rules, first of all, we need 1 cotangent and 2 cosecants. The other thing that we say with those rules is that when we differentiate a c function, it is going to be negative. So we know that when we take the derivative of cosecant x, we are going to get a negative. And let me be very clear, this is now taking the derivative. We will have y prime is equal to, the 7 is going to tag along, and then the cosecant is going to become a negative. Now you need a total of 1 cotangent and 2 cosecants. So you have 1 cosecant, so you're going to need another cosecant x, and then another, and an end a cotangent x. Okay, so that will be the derivative of this first term. Now for the second term, cotangent x, again, you know that that is going to give you a negative because you're differentiating a c function. And then because you have 1 cotangent, you're going to end up with 2 cosecants, and you'll get cosecant squared x. Now, I really don't like how I wrote this. Like, it should be one complete line here. So negative 7 cosecant x cotangent x minus cosecant squared x. Now, for completeness, like if you write this in on your test, that's fine. It is important to recognize that there is a GCF here that you could factor out. There is a negative 7 cosecant x in both of these terms. So if you look in both boxes here, both terms, you see that you do have a negative sign and a cosecant that you could factor out. So if you wanted to factor out the GCF, you would be left with negative cosecant, and then that negative would come out. So you would have 7 cotangent x, and then this negative is coming out in front, so it would be plus cosecant x. And that would be another equivalent representation of your derivative. And I do want to just mention, like, you don't have to do it this way where you are using the trig functions to simplify. You could, if you wanted to, you could start with the quotient rule, or you could do the quotient rule on this and the quotient rule on this. So there's lots of ways to doing it. This is just one way of getting the derivative using your trig identities.